Okay, so 1, 2, 3. Okay, actually for this lecture, I think we should have like 9 students. I'm quite shocked for this semester because last time, I mean for last year we get like 40 students, but for this semester we only get around like. So Luis, you choose this lecture? Okay, I see. Okay, I see. So I mean, yeah. So actually, we have roughly like 9 students for this lecture, and also we have maybe 9 plus 2 students from exchange students. Okay, let's is roughly about this lecture. Okay, so I think we should have like 9, maybe after the add and job period. Okay, so at least this lecture, I think we will open this lecture for this year. Okay. So today for first lecture, I first quickly go through the teaching plan. So before we start, so U3, any student from U3, U4, Chen Jun, U4. What about you? You're from U3 or U4? U4. Sorry? 30 years, right? Okay. So I mean, generally should be good enough for the prerequisites for this lecture. So before we start, okay, let's go through our teaching plan. So okay, so one more thing I want to discuss with you is that today you know, okay, from 6:20, okay, we are going to raise the Typhoon 6, number 8. So I received a phone call from the department. They say, okay, so if it's possible, we can dismiss this lecture like around 6. So in this case, you have enough time to leave PolyU or yeah. Because I'm not sure if you are live quite far around from PolyU. So if you're okay, so what about we dismiss this lecture around 6 o'clock? It's okay? Okay. So I will try my best to finish this lecture around 6. So so for those, so you're exchange student. So I think you are maybe not familiar with the Blackboard. So for polio teaching, so you should able to find a lot of information from the Blackboard. For example, for the first one, you can find the teaching plan for today. I mean for this course. So roughly we have around like. Okay, let me download first. Okay, so roughly we have around like 30 weeks. And okay, the good news for this lecture, okay, this is elective and open book. So in the final exam, it's going to be open book. And in terms of the assessment, so we have a midterm test. It's like snacks. Okay, it's very only small percentage, only 15%. And for the homework, we have roughly around 2 homeworks. So because like you can say for before the midterm test, okay, we have a homework for the homework 1, and after the midterm test, we have another homeworks. And also we have a group project. I mean, in the 12th and 13th, almost last week, we have a group project. So each of you are encouraged to make a presentation, okay, based on topics or the contents relevant to this course. Okay, so because previously we have like 14 students, so we spend roughly like two weeks to finish the presentation, but for this time we only have 9 or 10 students, so it's up to change. For example, you can assign one more lecture for the revisions for the final exam. So roughly it's like, okay, midterm test it's like 15, and assignment 2 assignments. Okay, take charge make up about 15%, and the group presentation is around 20%. So in this group project, okay, only presentation, no need to write the report. For the final exam, okay, it's open book, 15%. Okay, this is for the. Okay, I think you have already found this information before you select this lecture, right? So any questions for this one? Okay, that's great. So we have several. I mean, for this semester, we have carefully redesigned the lecture, I mean, content of this course. For example, we have invited at least 4 TA for this lecture, and each of the TA TA means the teaching assistant. So each of the teaching assistant are the PhD level. Okay, I think this can make, of course, benefit this lecture a lot. So for the okay, face-to-face BC303. So for the first week, okay, for today's lecture, it's quite should be quite easy. We are talking about the concept of the navigation and positioning, and also some content about the coordinate frames and different methods or to represent the position orientation stuffs. And also we provide, I mean, for each of the lecture, I try to provide not only the theories, which also I try to provide the codes, okay, I mean, based on the Python. So you can try, for example, we teach or we deliver some theories about the, like some mathematics about the navigation. We also provide the data, okay? You can program it with Python, and we also provide the codes. You can easily replicate the results. So this is, I mean, this is for, okay, we also provide the Python code together with some data. So, okay, the time is from 3:30 to, okay, system from 3 hours. And from week 2 to week 4, okay, so from week 2 to week 3, it's about GPS. GPS, okay, smartphone GPS. Okay, the first one is about how to use the GPS to do position, okay, calculate your location, okay. So for the second one, it's like how to use the GPS to calculate your velocity. Okay, let's say 30 weeks. So it's quite clear, right? So for week 4, there's no lectures. And for week 5, we are talk about the high accuracy GPS. So for example, this one is going to talk about the 2 meters level of accuracy from GPS. So this is going to be provided with the theories for velocity estimation. For example, provides the centimeter level accuracy of the velocity. And for this one, okay, this is going to be talk about the centimeter level position accuracy from GPS. So let's see roughly GPS, part 1, part 2, part 3. Okay, so frequent in-class test and face-to-face. Okay, so this is for the GPS. And for the week 6, I think this lecture is going to be very interesting. We are going to okay, provide with some smartphones and also some GPS receivers. So you can take the smartphones. So any of you use the Android smartphone? No? Okay, two, okay. So for the Android smartphones, we can directly use your Android smartphones to collect the GPS data. So I think this is good. So for those who use the iOS, okay, use the iPhone, so we are going to provide additional Android phones for you to collect the data. So in short, this is a lab. Okay, we call it tutorial. You can call this is a lab. So in this week, we are going to like collect some data outside, just walking around. We can collect some data to do the processing to get your trajectory based on GPS. Okay, so you can directly play with the GPS data, okay, to see, okay, what is the position accuracy looks like. So for week 8, okay, this is going to be a midterm test. Okay, week 8 is a midterm test. So for the week 9, okay, we are going to talk about, okay, week 7, week 9, this is going to talk about how to use the camera, okay? For example, like smartphone is a big platform. There are a lot of sensors inside, okay? So for example, in the surrounding this sketch, there are a lot of GPS receivers. Also, we have the cameras. So the cameras can also be used for the positioning as well. So I mean, for lecture 9, 7, we are going to talk about the visual-based positioning, how to use the camera for positioning. So for the week 10 and week 11, we are going to talk about the sensor fusion. For example, if you have information from different sensors, so for example, GPS, for example, camera, okay, they provide different informations for positioning. So how to fuse, how to optimally fuse the information from different sensors. Okay, this is going to be introduced in the week 10 and week 11. Okay, so last 2 weeks, case study. Okay, case study means we are going to talk about the group presentation. Okay, so because we only have like around 10 students, so maybe we only need 1 week for presentation, and last week we may have a quick revisions for the final exam, roughly like this. So this is for the teaching plan. So concepts, GPS, visual positioning, sensor fusion, presentation, and together with one lab. Any questions? It's quite clear, right? Okay, so this is for a teaching plan, okay? So before I start into the main content, I wish to make okay, ChatGPT, okay? Always this is a problem. So the good thing is in this lecture there's no report, okay? Otherwise you can okay, ChatGPT is always your best friend, right? So in this lecture, there's no ChatGPT for report preparation. So I mean, I wish to like quickly go through how to. So first is like I want to deliver the guidelines from the university about how to use the ChatGPT, and the second one is about my personal sharing, like how to use the ChatGPT to help you to learn better in this lecture. So okay, this material is provided by Dr. Ken from AAE. So AE still there? Everyone should be from AE, right? AE, AE, AE department. Okay, okay. So Dr. Kane is from AE. So as we all know, so especially for now, we have encountered a lot of opportunities and a challenge from ChatGPT. So of course we know, for example, it's good to use the GPT to help you to provide the outline. For example, if you want to write a thesis, right, you provide some prompts, and it will help you to provide the outlines. For example, how to organize your report. So of course, we have a lot of problems. For example, some students relies 100% from GPT, so they almost like never change some basic rules from GPT. Okay, so this is the challenge. So again, it's challenge in the front, and of course, opportunities in the front. So for example, let's read words. Okay, the keywords is academic integrity of assessment task. So it's especially for PhD. So the first lecture they take, I mean after they get into PolyU is about the integrity, academic integrity. So this is very important. So second one is like the thing in on assessment design. So for example, it's my role how to rethink about the assessment design. But luckily in this lecture we don't have any report. Okay, you don't have the chance to like seek help from GPT. So output can be a very high quality. Okay, let's and actually from Polyo you can easily have access to this one. Okay, you just search Polyo Gen AI. You can easily have access to Polyo Gen AI. Have access to the ChatGPT. So okay, so for, I mean for current stage the digital literacy is very important. So for example, like the critical thinking. So because we have a GPT, so all those capabilities is difficult to be trained because everything is already considered by GPT, provide the outlines, the logical thinking capability is not changed because of the GPT. So this is about the challenge in the front. So at least, okay, later I will mention like, for example, in this lecture, how to use the ChatGPT to provide with the basic codes. For example, the Python codes to help you to analyze the data. So for example, like, okay, you have two trajectories from GPS. So how to calculate the differences between the two trajectories? So the trajectory is represented by a CSV file. So for a lot of numbers, right? So the Python can easily helps you to provide the scripts, like some basic function to calculate the differences. Calculate differences. Okay, I just quickly go through. Let's see the materials provided by the department. They wish, they wish us to deliver this information to you again and again to emphasize the importance of appropriately use the ChatGPT. Okay, so originality it means okay you should finish. Okay, you can use the ChatGPT to help you to organize your report, but it still means you should like 100% rely on the GPT. So originality means it's a sign of integrity. It's essential for creativity. It's a legal requirements. So I will also upload this slide to the content of Blackboard. Okay, you can just refer back to this slide. Okay, so those guidelines respect your own work and the work of others and the foreign guidelines. For example, like if you really use the ChatGPT to prepare figures, for example, in this lecture, we have presentations, right? So for example, when you prepare a slide, you may refer to ChatGPT to generate some figures. So you can just add a citation or just courtesy. Okay, ChatGPT, this is good. At least you try to respect the source. Okay, the source is coming from GPT. Okay. Okay. This is why we have the rules. Okay, because some students break the rules. Okay, the don'ts. Do not rely solely on the AI-generated contents as the source of information. Do not ask Gen AI software to write your essays. So do not input any personal details of confidential information when using the Gen AI tools. So those, okay. So those are some examples like, for example, in the last year, one of final year project groups. So they have used ChatGPT to, no, this is not a bad example. This is a good example. They use the ChatGPT to, they use the ChatGPT to polish their language. But finally, when they submit a report to the department. Okay, department just check the similarity of the AI similarity. So they find it's pretty high. So they say, okay, department just argue, okay, are you fully, relies on the GPT? So they say no, because they have the records. So after they finish one version of the reports, they try to polish the language using ChatGPT. So it means they have to do the basic works, like they only use GPT for polishing, okay, for language editing. So this is a good way to show that, okay, we have all originalities. We use the GPT only for the polishing, for the language editing. So okay, this is my personal sharing. For example, we can like, okay, so how many of you have done the Python before? Python. 1, 2, 3, 4. Okay, that's great. That's great. In this lecture, we have like for GPS positioning, we are going to use the Python for the positioning. So for example, like okay, so let's try some examples like how to quickly use the ChatGPT to help you to generate the basic course. For example, just search from. Okay, search this one. You can just quickly look into. Okay, look into this website. So you should have access to this one. So for example, usually if you want to generate image, okay, it will like make use of a lot of credits. So for example, like Stable Diffusion 3, it will going to, if you generate one image, it's going to be cost about 65 credits. So for academic stuff, I think we have around 10K credits. So usually you just use the first one, just use the first one. So for example, GPT 4.0 for 0. So for example, like in here is an example, okay? So if I want to, the prompt is Python code to, okay. So for example, if I use Python, I try to learn, or I get a task, I try to like okay, I try to plot a function, okay? For example, I try to plot a function. For example, a sine function. Because in the future we will do the lab, okay, we need to use the Python to process the data. So for example, this is the example, okay? It's okay. I also think this thing quickly helps you to learn the Python, So for example, lots of tools, lots of web-based tools. Okay, this is a web-based tools. Okay, based on this. Okay, just this is the link. This is the link. This is more like an online editor, okay, for you to debug the code based on the Python. For example, just Copy this. Okay, so copy the code here and click this item. You're going to get a function, I think. Okay, you see, you can quickly learn. Okay, for example, to get a sign function. So based on this, you can learn to, for example, if you change something, for example, change this. This is pi, and for example, okay, change this parameter to about around 4. You're going to get a new functions, right? So in this case, you can quickly, okay, pick up the basics of the Python. So for example, in the future, when we need to plot some trajectories from GPS, you can quickly seek help from GPT. I think this is good. This is good because it's not necessary to write everything yourself because it's repetitive works. There's no innovation in the front, okay, inside. So in this case, I think you can try to use, for example, like you can even generate some. Okay, for example, you want to do this double plus, okay? This may be slightly different. For example, if you want to, okay, it will quickly helps you to plot the same function as well. But the difference thing is that, so if you use the double plus, it's not easily, it cannot be run in the Chrome, okay? You need to install some VS Code, you need to install some editors. VS Code is from Microsoft. So this is from my personal sharing. For example, if you want to learn the programming, okay, you can just really scale from ChatGPT. Okay, so this is about the Gen AI. So also later I will upload this slide to the Blackboard, okay? So let's go back to the lecture. Okay, so let's go back. So this lecture, okay, the um first week, fundamental concepts for the guidance navigation. So the name is 403 Guidance Navigation. So you can call me Wilson or you can call me Dr. Wen. I'm assistant professor from AAE. AAE is Aeronautical Aviation Engineering. So this is week 1. So let's start. So quickly about myself. So my keywords. So my keywords is autonomous systems. Okay, so if you talk about the drones, or you talk about the cars, autonomous cars, I work on this. So also I working on the collaboration between the drones and the cars. So for example, my background includes I received my bachelor from 2015 and master degree from 2017 is from mechanical engineering. It's not AAE, but the thing I learned is the mechanical engineering, this subject is quite general. It learns a lot of things like aerodynamics, mechanics, control, and mathematics. A lot of stuff is very similar to the information requires for the robotics research. So after that, after my master degree, I have roughly around like 1 year industrial experiences in a startup company. So this, okay, after 1 year, I leave this company. Actually, I was the co-founder. So usually they just say I lose the chance to be a millionaire because I was the co-founder, and this company is currently it's like around 1K employees currently. So after that, I go to PolyU. I go to Hong Kong. Okay, this is in Beijing. Okay, this is in Beijing. So after that, I go to Hong Kong to start my PhD from 2017, and also have one like roughly half a year visiting period in UC Berkeley. So after that, I start a postdoc and research assistant professor academic staff career in PolyU, and in 2023, I start like assistant pro. So the motto of PolyU is to learn. Did I do the sharing? Yes. So the motto of PolyU is to learn and to apply. It means you learn from classroom. I apply to the society. Okay. So that's why in the top right. Okay. We do a lot of collaborations. Also, of course, we do a lot of fundamental research. Okay, like a lot of equations, blah blah blah, from like develop something from 0 to 1. And also we do a lot of research collaboration with industry, for example, like Tencent, Huawei, and also Meituan. So for example, currently we're working with a company in US working on the drones. We had a lot of collaborations because we also want to challenge or research achievements. For example, if you develop something, so how to verify your algorithm or technology is feasible to the industry or to society. So that's why we do a lot of industry collaboration with those companies. And also in academia, I working on the several society. So those society is it's like more like an academic club, okay, academic club. So in here, I working on the Robotic Society and the Intelligent Transportation Society. So this is specifically for the Navigation Society, ION. So this is so-called the Institute of Navigation. So-called the Institute of Navigation. So also I get around 33. Okay, this number should be around 40 or 50 something. So also session chair in several conferences, and those are the collaborators from North American to European countries and also mainland China. Okay, so this is roughly about me. So my keywords is navigation and autonomous systems. Okay, that's roughly about me. So those are the research facilities. I mean, we're working on the cars, on the drones. So if you have interest in all research like auto systems, like cars and drones, so feel free to join us to maybe like drop email to me to see if you can collaborate or not. Okay. So those are different levels of GPS receivers. Okay, for example, this course is mainly working on GPS receivers. We have different levels of GPS receivers. Like we have a lot of smartphones. Okay, we have a lot of smartphones in our lab because smartphones, like to be honest, so why we have a lot of smartphones? Because the smartphone positioning in the urban chaos is not good enough. So we're working with industries to try to develop the relevant technologies to improve the positioning accuracy of the smartphones in urban chaos. So that's the reason behind. So okay, so roughly we have around. Okay, I close this one. It's quite unreasonable. Okay. So this for this lecture, I just mentioned we get several TAs. We get several TAs. It's really annoying. Check. Okay. So in this lecture, we get 4 TAs. Okay, they are going to work with us for the assignment and for the tutorial for the lab. And okay, I think we have time because we only have 8 students. So let's quickly get familiar with each other. Okay. So what's your name?
My name is Emily.
So where I come from?
France.
Or friends. Okay, nice to meet you. So about you?
Hi, my name is Max. I come from London.
From where?
London.
Okay, London. Okay. So yeah, you four students. So what is your subject in London? What's your subject? I mean, what you learn?
Aerospace engineering.
Oh, aerospace engineering. So what about you?
It's like more like general engineering, but into aerospace and aeronautics.
Oh, I see. I see. So you're going to stay in Poly for 1 year or not? Just 1 semester.
1 year.
1 year for you. Okay, I see. So what about you?
I'm Alan. I'm from Hong Kong. So studying the air transport engineer.
You are senior intake?
Senior.
Oh, so currently you are U3 or U4?
Yes, we.
U3. Oh, I see. Okay. So yeah, what about you?
Oh, I'm Sahat. I'm from A. I'm in year 3.
U3 ATE or AE?
A.
AE. So okay, Louis, right? So U3, right?
Yeah.
Okay, so Chen Jun.
I'm from AE.
So okay, AE. Okay, so where's that? What about you?
I'm Gary and studying ATE.
ATE, U3 or U4?
Yeah.
Okay, who is your FIP supervisor?
Lao, L-I.
Oh, Dr. Lau. Oh, captain before, right? He's captain before.
No.
Professor Law, you mean Professor Law?
Yeah, Professor.
Professor in practice?
And Lao Wei. Is it WEI?
Ah, Lao Wei. Oh, I see. Dr. Dr. Liu Wei. Okay, we understand. So, okay, Yang Qian LTA on the back. Okay, so that's great. It's pretty fast because you only have 8 students. So, okay, let's go ahead. So I always encourage students to be open-minded, speak English, and participate in the activities assigned. Especially in this lecture, we have the so I mean in this lecture I want to emphasize this lecture is open book. Okay, it should be easy. It should be easy to get reasonable scores. It's open book as long as you finish your assignments and the group presentation, and this is elective lecture. And also, yeah, because I have teach this lecture, this is the first year for me to teach this lecture. For each year, I try to upgrade the materials to get track of the latest information. For example, in this lecture, I also combine the Python programming. So previously, we working on the MATLAB. But currently, the Python is even more easy to access. So I think maybe in the coming 5 years, the MATLAB will be fully replaced by Python. So you may have done from Polio. Polio have buy the license this year, right? Do you know why? I think it's because the subscription fee is reduced dramatically this year. Because previously it's too expensive to buy. This year, every student can use it. So for example, in the last year for HM academic staff, we need to share a license ID with other staffs. So currently, so my insight like in the future, in the coming 5 years, I think the Python will fully replace the MATLAB in the coming years. So that's why in this lecture, I try to get rid of the MATLAB, okay? So for teachers, okay, arrive on time, reply emails on time, and answer questions related to the subject. So for this one, I also have a very good sharing, okay? Very good sharing. So we built a GitHub. I think if you are a student from the engineering society, of course you need to know what is GitHub. So for example, you need to do the programming, okay? If you need to do the programming, you need to know what is GitHub. So, okay, you can find this link from the slide, okay, from the Blackboard. So I generate this GitHub page. So for example, in this GitHub page, I provide the several photos. For example, the lab, okay, the lab are going to provide the information in the lab and sample codes. So for example, in Python, in the future, you need to use the Python code to do the GPS positioning, right? So I provide the basic codes, lecture videos, lecture notes, general documents. So for example, in this page, okay. So for example, we have several TAs, right? So this is me, this is a GitHub account. So I mean, after this lecture, you can register an account, okay, from the GitHub. So for example, this code is fully, you see the language is 100% based on Python. So this is a lecture information for me, for my address, and also for the TA, and for the lecture venue and time, and also for the class schedules are all here, okay? So for example, the codes, you can click this one, you can find the code. Okay, for example, the Python codes can be found here later. Later on, okay, for the questions. Okay, I think this is the most powerful part for this GitHub repository. So for example, if you have any questions, you can get into this issue button, okay? This category. You can raise the issue. For example, if you have, okay, I need to sign up. So you can just raise an issue. You can easily raise an issue here to ask a question. So in the later hours, I'm going to look back to, so if you raise an issue in the GitHub, okay, I will receive a message from my email. So I will reply to you in this issue. So the benefit is like, if you raise an issue, other students can also look into this issue. For example, if you have similar problems, for example, in the lab, if other students have similar problems, they can look back to this issue. Okay, they can easily get the solution. In this case, I don't need to reply again. And also you can easily get track of the solutions. And the most important part for GitHub is of course the collaboration of the codings. So for example, if you have several team members, right? Okay, for a given task, you can divide the task into task A, task B, right? So I work on this branch. Another student is working on this branch to finish different task A, task B. And finally, I can combine the two branch together to finish the task. It means based on the GitHub, we have several branch, we can collaborate. This is called version control for the coding, especially in Google. So you may know Dr. Shi, this another academic side from our department. So he's working from Google for 1.5 years. So he learned quite a lot from, he benefits quite a lot from the version control of the codes. But actually in Google, they say they have their own GitHub, but basically they are similar. They use the similar principles. So this is the page looks like. So again, so if you want to, if you have any questions, you can raise the issue. Okay, raise the issue in this part. Okay, I will receive a message by email if you raise the issue, and also you can look into all the materials from this GitHub page. Okay, GitHub page. So any questions? Okay, let's go back. Okay, ask questions in GitHub. Okay, so be motivated. For example, in this lecture, I have prepared a lot of information for GPS and for Python coding. So if you, be motivated, I'm quite sure you can learn quite a lot from this lecture. Because actually for guidance and navigation, this lecture we talk quite a lot on GPS. Okay, as I mentioned in the teaching plan, we talk about GPS, visual positioning, and sensor fusion. So actually the positioning on navigation is one of the most fundamental parts for the robotics. So for example, currently we have autonomous driving cars, we have the UAV, we have the drones. So all those systems belongs to the autonomous systems. They all relies on the positioning. They all relies on the reliable positioning. Okay, so this lecture is the fundamental parts for the autonomous systems. So intended learning outcomes. Okay, the first one is like working principles of navigation and the guidance system, and the mathematical concepts for the navigation. Actually, this part is mainly talking about the fundamental mathematical model or concepts for the GPS. And for this one, it's going to be procedures, and last one is about the technologies. For example, in the future, when we talk about the sensor fusion, okay, how to talk about the sensor fusion, how to use the knowledge we have learned from next lecture to do the sensor fusion. So for example, in this lecture, we talk about the fusion of a GPS and odometer. So in the future, if you have get a new task, like to fuse the information from maybe GPS and the LiDAR, so you can also design the sensor fusion estimator as well. Okay, so for assignment, I want to emphasize this strictly no late submission, and final exam is open book. And this is the basic requirements. I expect you to learn yourself. Okay, so it's good news is like majority of you have already do the coding before based on Python. So assurance on the attendance. Okay, so in this lecture, I'm not going to sign attendance. Maybe some other lecturers they do this. They try to provide a QR code for to sign attendance. So yeah, the bad news is, for example, if you only get 10 students in this classroom, if all of you are not attending this lecture, are going to talk to the classroom. So this is the bad news, okay? So try to assure attendance, okay? Try to assure attendance. So this is teaching plan, okay? Teaching plan list is the same as the one provided in the Blackboard. So okay, week 6. Okay, week 6. This is the lab, okay? Coding with Python for GPS positioning. And week 8, okay, midterm and sensor fusion. And also week 4, there's no lectures. So again, any questions for the teaching plan? Okay, that's great. So this is what I just mentioned to you. So frequently are going to update this website. So for some of the materials and also for the lab and for each of the lecture, we have some examples. Like for example, like a GPS positioning, GPS velocity estimation. For each of the lecture, I'm going to provide some example codes. So all the codes can be found in this repository, in this folder. Okay, sample course. Okay, so this is for the GitHub. So for today, okay, maybe we can take a break for 5 minutes. Okay, take a break for 5 minutes.
Do you have to take this on all year? So it's not really like next semester. There will be other exchanges to do. Come back. Semester, there'll be a bit of a batch of Europeans. Yeah, so. Yeah. Would you stay? Would you stay for the whole year? So I believe it's okay.
Okay, so let's go back. So this outline for today's lecture, I think is quite relaxed. So the first one is the guidelines. Okay, I already mentioned this. I already talked about the guidelines for the GNAI. And second one is the applications of the navigation technology. So for example, what is the role and the typical sensors for navigation? Okay, like camera, GPS, LiDAR, like MU. MU is a sensor we can have inside the smartphones. So the pros and cons of different navigation sensors. And for example, we have different sensors, right? So of course they have their pros and cons. For example, the accuracy and also the cost of different sensors and the coordinates. So for example, if we talk about the navigation, talk about the positioning, okay, of course we need to have a reference coordinate. So for example, if you say, okay, your position is 10 meters, XYZ, blah, blah, okay, XYZ is respect to which coordinate, okay? So you need to have a coordinate system. So for example, for GPS, you have several, popular coordinate system like ENU coordinate, east, north, up, ECEF, and body frame, okay? The three coordinate system is good enough for the typical applications. And also for the transformation between different coordinates, the transformation between different coordinates. So for example, like how to transform from ENU to ECF and from ECF to body frame. So how to make this transform. So, okay, the definition. So any of the several, okay, let's say definition of navigations, right? This is from Wiki. Okay, this is from Wikipedia. So the definition is like any of the several methods for determining or planning a ship's and aircraft's position and caused by geometry, astronomy, and radio signals. So those are the definitions. Sorry, those are definitions of the navigations. So for example, we talk a lot for the radio signals currently. So for example, in this room, okay, we have Wi-Fi, right? So for example, if you get into the indoors, I'm not sure if you have such experiences. So for example, if you get into a supermarkets and in the outdoor, it's great. You have GPS. In the supermarkets, okay, it's indoor scenarios like it's GPS denied. There's no GPS. So even if you don't open the Bluetooth or the Wi-Fi, the positioning is going to be terrible. It cannot locate which building you are. So if you luckily, because a lot of people they don't know this, if you open the Bluetooth or if you open the Wi-Fi, so at least it can provide the location accuracy of like within which building. So that's why Wi-Fi belongs to a radio signals, right? So the Wi-Fi, we have a lot of Wi-Fi routers in this room, in this building. So the Wi-Fi signal is one kind of a radio signal. So for the GPS, it's also called, it belongs to the categories of a radio signal. So currently there are a lot of radio signals surrounding us, like 4G, 5G, the Bluetooth, the Wi-Fi, okay, Wi-Fi RTT, different kind of radio signals can all be used for the navigation purpose. Okay. So for example, like in the smartphones, okay, we have the different sensors. And also currently we have the smartwatch. So one of the hot topic currently is like, so how to combine the navigation and also the healthy information. For example, like smartwatch. Okay, there are some healthy monitoring sensors in the smartwatch. So that's why. So majority of people buy a smartwatch. They are not used for just keeping the time. They are used for monitoring the healthy conditions, heartbeat, the blah 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 stuff. So they are talking about the healthy. And also we have vehicle navigators. We have vehicle navigators. Like okay, in the past we may have like I'm not sure if because you are the young generations, you are at least 20s something. So before, if you drive a car, there's a navigators in a car. It's like a big box inside the car. Let's say the navigator. So before they also use the GPS, but currently we have smartphones. Each time we drive a car, we just okay stick our smartphones to the cars. It's good enough for us to navigation because the smartphones already have a GPS. The accuracy is already good enough. This is already the old stories. this is one of the demonstrations of the smartphone positioning using different solutions. So at least I mean in the urban chaos, the smartphone I mean in the like I will not say urban chaos in the mid-terms urban scenarios like with some buildings but the building is not too high, the smartphone can roughly provide the accuracy of around 5 meters. So the whole of 5 meters is achieved. This is based on a lot of sensors in the smartphones. So for example, in the smartphones, they have GPS receivers. Okay, and antenna is, I mean, the antenna of the receiver of the GPS is surrounding this smartphone. Also, there is inertial measurement units. For example, if you play smartphones, okay, playing games, they have it can provide the orientations, right? This is based on the IMU. It's called inertial measurement units. This should be inside this smartphone. Okay, GPS, IMU, and also they have a camera. Camera can also used for positioning, and also they have the parameters to measure the altitude. Okay, and they also have the Wi-Fi. They have Bluetooth. All those sensors can be combined simultaneously to achieve 5 centimeters. 5 centimeters. Okay, this is one kind of results. Like okay, if you have the IMU together with the GPS, I mean at least the trajectory looks quite smooth. Quite smooth. This is one of the testing results in Hong Kong. Okay, it's in Narrow Road, maybe Narrow Road near Polyu. Okay, this is one for the testing. So navigation, as I just mentioned, okay, so the navigation is one of the fundamental components for the auto systems like auto-driving cars and also for, okay, let's look into this. This is a video from Tesla. So this is one of the very representative videos showing the auto-driving cars. So for this autonomous driving cars, the basic function includes the automatic control and automatic navigation. So for example, if the car wishes to drive from one point to another point automatically, so of course he needs to know where it is and how far it is from the destination, right? For example, if this car wishes to drive from Polyu to USD, at least he needs to know where it is and how far it is from Polyu to USD. So in this car, the major sensors they use is of course the GPS. The second one is IMU inside the car and the odometers. For the wheels, they have the encoders to measure the rotation of the wheels. And also they have the parameters and also the cameras for positioning. But according to the news in the last several months, this video is raised in 2017. But last year, according to news, this video is a fake video. They post editing this video. Okay, this is not a real case. Okay, anyway, let's say something. Okay, say something like okay, at least he didn't touch the control pedal. Okay. So another one is like, okay, in Polyu, we also working on like, sorry. For another one, okay, sorry, I don't have the VIP, maybe, yeah. Okay, so this is autonomous driving cars. We're doing a testing at Polyu. This is quite close to the W core. So this car is, I mean, it's drives autonomously in Polyu, and there are several sensors on board. It have GPS, they have IMU, and also we have LiDAR sensor. So for example, we can do some basic collision avoidance. So in this system, okay, we have applied almost all the navigation sensors like GPS, IMU, and also the LiDAR sensor together with camera. So actually there's a monitor inside, so you can see the results of the object detection. For example, the pedestrian detection using AI. So this is the cars at Polyu. This is also from our research group. So okay, so we also try to design a new car. You see, this is not in good look, right? For this one, we invite a designer, okay, with a sense of the art to design this new car. It looks like quite cute, right? cute, and the white color gives you a sense of safety, right? The white color can give you a sense of safety. So this is newly designed, but currently we don't have the funding to make this control. The problem is like this. This is only in the stage of the design. Okay, so this is another video for the drones. So this is a video from CMU. So currently we also have our drones already. So maybe next time I can replace this to a polio video. So what I want to say in this page is like, so for a typical autonomous system, for example, like for the drones or for the cars, for example, like for the drones, if you want to autonomously deliver a package or luggage from polio to UST, so the first one is that you need to do localization. You need to know where you are. Okay, so that's very important. At least you know where you are and how far you are from the destination. So this is the first functionality part, okay, perception. The second one is like scene understanding. You need to know what is in the front. And also includes the path planning. What is the optimal path to the destination? And last one is of course the control, right? You need to control propellers or control views of the cars to approaching your destination. So you see, the perception localization is the most fundamental part for the auto systems. This is going to be delivered in this course. So this is the software check stack of the auto driving. So for example, the first one is the sensor input, like camera, radars, the camera, radar, and the lidars. So based on all those different sensors, we can do the perception localization. And after that, we can do the prediction. For example, we need to predict if there's any pedestrians in front and what is the behavior of the pedestrians in front. So the last one is the planning and control. So this is the investment of the money. I mean, from US and from mainland China, they invest a lot of money. So you can see, okay, the investment of the money inside the research about the unmanned autonomous system is like this is from US. Okay, so this from China. Okay, there are some differences, but difference is decreasing. But in short, globally, the investment is increasing year by year. Okay, year by year. This is investment of the inside the research of the unmanned autonomous systems. So the unmanned autonomous systems, this words includes all the unmanned systems like autonomous cars, like autonomous drones. Okay, they all belongs to the unmanned autonomous systems. So for the smartphones, as I just mentioned, we have a lot of sensors, right? For the smartphones, at least we can count range. Okay, for example, like the MU is inertial measurement units. And also we have the parameters to measure the altitude. We have the camera, the GPS, and the Bluetooth. BLE is the Bluetooth. And the Wi-Fi, 4G, currently we have 5G for different radio signals, all can be used for the positioning. And based on this different sensors raw measurements, we can get some information like the height, like the orientation, optical flow. We can have some algorithms to fuse different informations like the particle filtering or Kalman filtering. So finally, you get a location, velocity, and the accuracy confidence. Accuracy confidence means how much you can trust in your positioning solution. How much you can trust in your positioning solution. So those are the setups of those different sensors in your smartphones. So for example, we have temperature sensors, parameter, magnetometers, gyroscope. So for different sensors can be used simultaneously, okay, to do the positioning of our smartphones. So generally we can divide those positioning sources into two parts. The first one is called the point positioning. So for example, the GPS. The point positioning is like, okay, so for example, this, okay, upper right side, this figure. So the position of the satellites, it's a non-variable. The position of the satellite, okay, this is a non-variable. It's running surrounding the Earth, right? The trajectory, the orbital information is already a non-variable. And also the satellite can measure the distance from the satellite to receivers. It means this position is known. So this range is also known variables. And you receive information from multiple satellites. You want to calculate the position of this receiver. So this is called point positioning. It is drift-free because this information can directly be determined by single epoch information. Epoch means single timestamps. So I mean you can directly get your position based on information from single timestamps. So for example, like the ultra wideband, this is called UWB. This is also a kind of technology to measure the distance, measure range. The second one is Wi-Fi, the cellular communication based on 3G, 4G, 5G, and also the satellite navigation. So this is so-called the point positioning. Point positioning is a single point, directly secure positioning, okay, based on the single timestamps of information. So the second one is like called direct reckoning. Direct reckoning means it only provides the relative informations. So for example, like from inertial measurement from IMU. So what the IMU can provide? So for example, in the smartphones, we have IMUs, right? So IMU can provide the linear angular velocity. Angular velocity, it means the change. It provides a change. It means it can only helps you to infer the change of your position or velocity. For example, based on IMU, you can infer how much meters you have goes through from one point to another point. It means your position is determined by at least 2 timestamps. It's like accumulation. It's quite different from the first one. First one is like point positioning, only based on single timestamp is good enough. So for IMU, it's like to do the accumulation of your velocity. Okay, make an integration of velocity with respect to time, you get the position change, right? So also we have visual sensors. Okay, this can also help to infer a change. For example, infer a change from x1. X1 is the position at the first timestamps. Okay, so after you make use of the measurement from LiDAR, visual, or inertial measurement, it can help you to infer a change delta x, infer a change of the position or maybe the velocity. Okay, infer a change. So this is the major difference between the point position and direct reckoning. So any questions? So this is the general figure to show like, I mean, for different sensors, previous page we mentioned the point positioning, right? And also the direct reckoning. Okay, based on the 2 timestamps information, we can do the direct reckoning. So the first part is like you call sensing. Okay, let's see the framework of the sensors to navigation. So the sensing means we collect the data. Okay, for example, like smartphones or GPS. Based on the sensing, okay, we can collect the data. For example, for GPS, we can collect the signal-defined receiver. Based on this, we can collect the raw measurements. Okay, the radius signal from the satellite. So for example, the IMU can provide the acceleration and the angular velocity, and also for camera, it can provide the features. So those are the measuring part. Okay, so after that, you can get the raw measurements. So for example, for the GPS, we can get a shoot range. Okay, in the next lecture, we are going to talk about what is shoot range. So shoot range represents the distance from the satellite to the receivers. Okay, this is called shoot range. And for the INS, it can provide the accelerations. Acceleration means, okay, the differential of velocity, how the velocity change between 2 epochs, 2 timestamps. And angular velocity means, okay, x, y, z, 3 different directions of the rotation. So what is the change of the rotation? So this is so-called angular velocity. And for, okay, features, we get the associated features. And finally, we can do the estimation. Okay, estimation. So in the next lecture, we are going to talk about the least square. So by doing the estimation, we can get the relative position. Okay, so this is called direct reckoning because this can only help you to infer the change of the position in 2 timestamps. And this is the point positioning. Okay, so provides the point positioning. So which is independent from the, for example, you can directly get a position at the single timestamps based on GPS. So this is also called the point positioning. So it's clear? Okay. So point positioning may be inferred. Okay, let's see the examples. For example, for the Wi-Fi, for example, based on Wi-Fi, this is a Wi-Fi routers, okay? So the Wi-Fi, send a signal to the smartphones. Okay, it can measure the range from the Wi-Fi routers to this users, right? So because the position of this Wi-Fi router, so also this is called access point, okay? The Wi-Fi router is also called AP, access point. So this position is non-variables. This position of the router is non-variables, and the distance is a non-variables. Okay, this is a very straightforward positioning problem. So this is non-variables, the range, distance is non-variables. So how to estimate the position of a smartphone? Okay, this is quite straightforward. So this is belongs to the point positioning. Okay, for example, like such as Wi-Fi positioning. So the second one is like sometimes we have the distant landmarks. So for example, okay, so this is the landmarks. This black one is like landmarks. So if we continuously measure the distance from this to the landmarks, we can finally determine the location or the trajectory of the users. Okay, like this. So for example, this is the sensor fusion resource. This is purely based on the directly. For example, based on MU, it will drift away from the ground truth. Okay, this is a reference trajectory. Actually, this is the color blue. Blue is the ground truth. The red one is the proposed solution based on the fusion of the landmark and the MU. Okay, one more time. You see at the beginning, okay, the MU based directly is quite close, but with time going on, it's going to be drift away from, deviate from this ground truth trajectory. Okay, so this is the difference between the point positioning and the directly. Okay, directly you can also say this is so-called the relative positioning. Okay, it tries to infer the change of your motion, the change of your position over time. So this is the way, I mean, as I just mentioned in this page. Okay, this is a non-locations, right? And also you get the non-variables, the range. Okay, so how to get the position of this users, right? So this is the mathematical explanation. So for example, okay, so on the left side, the TX2 and TX1, this is the transmitter, the signal transmitter. So the location of the TX2, TX1 is non-variables. I mean X2, Y2. For example, okay, this is the position of the Wi-Fi access point. So this is the position of the second Wi-Fi access point. So also because the access point is already installed somewhere in the buildings, right? So we can use some geodetic solutions to measure the location of the Wi-Fi access point. So it means the A1, TX1, TX2 is a non-variables. So the XY, R means the receivers. So the T means the transmitters, right? So what you want to calculate is XY, and also the range. And also range, the distance from this point to this point is also non-variable. In this case, we can form two equations, okay? For example, the first equation is, this is the distance equations, right? From, because R1, R2, this is the distance from the receiver to the transmitter. So this is so-called the measurement, means this is the non-variables, So the only unknown variable is the position of XY. Okay, so the receiver's location is non-variables x1, y1, x2, y2 is also non-variables. So what you want to calculate is xy, and this is directly received from the sensors. Okay, this is the no measurements. So based on these two equations, okay, we can make some movements. So for example, if we stack the first equation, we are going to get the first part, and we do some redefinition of x squared, y squared. So finally, we are going to get this matrix equations. So I mean, each of you should at least learn the linear algebra, right? Yes, linear algebra. For example, like calculations of the matrix. Okay, so in this case, we can transform these three equations into this matrix from. Okay, this R1 is corresponding to this, and xy is unknown variables, and R is corresponding to xy square. So finally, we can write this multiplication into the matrix form. This is A matrix, this is X, and this is B. It means the only unknown variable is inside this xy. So in this case, if you can write down your equation into the matrix, this can be easily solved by the Python or by the MATLAB. For example, here you can just quickly do the inverse. So the inverse, you can calculate the x should be equals to A inverse B. Okay, this is good enough, right? Okay, so I mean this can be quickly done by the MATLAB or by the Python. Okay, so this is the examples. So for example, okay, you can do this. You can solve it if you only get two transmitters, right? So for example, if I have 10 different Wi-Fi access point, so TX1 from TX1 to TX10, okay, it means you get 10 equations. You get 10 rows, 1, 2. Each rows, actually this rows is corresponding to the first transmitter. The second rows is corresponding to the second transmitter. If you get 10 different access point, you're going to get 10 different rows. Is that correct? So if you get 10 equations, so this can be solved directly based on what you have learned from high school, right? But if you get 10 equations, you can still solve it. So this is the problem. So that's why we need to write down this into the matrix. In that case, we can make use of the high computation power from the MATLAB from computers. So this is the point. So for example, this is a quite rare case. I mean, in a satellite position in GPS, usually we receive signals from more than 4 satellites, maybe 10 satellites. It means you have 10 equations to solve. So that's why this is almost impossible, like to manually do the calculation. So we still need to transform the problem into matrix form, and finally solve it efficiently with the smartphone computation power. Okay, so yeah, how many signals are required to calculate the position of the receiver? Of course, 2, right? Because you have 2 unknown variables. Because we have learned from high school how many variables you want to calculate, it means at least how many equations you need to solve it. For example, if you get 2 equations, if you get 2 unknowns, at least we need 2 equations to solve it. Okay, so this is for this. Okay, so TDOA. You may curious about how this distance is calculated. Actually, this is called a measurement from receiver. This is calculated based on what? It's based on the time difference of arrival. For example, the signal is transmitted from this at T1. And after several nanoseconds, the signal is received by this receiver at T2. So T2 minus T1, this is time of the differences of the signal flying, right? So the speed of the light multiply, because this is a radio signal, the speed of the signal is equivalent to the speed of the light, right? So in this case, the time difference T2 minus T1 multiply the speed of the light. This is the distance. So this is how the distance calculated from the sensors. Okay, so this process is called the time difference of arrival. So this is quite straightforward, right? So the definition is also known as the time of arrival difference. Is a method used for geolocating the RF signal. RF is a radio frequency signal, okay, radio signal. So the principle behind TDOA is based on the measuring the differences in time at which a signal arrives at multiple receivers at different points. So for example, transmitted at T1, received at T2. Okay, the difference is T2 minus T1. This is the differences, and multiply the speed of light, you get the distance. Okay, this is TDOA. So the Wi-Fi RTT, okay, Wi-Fi RTT is a very good example, belongs to the TDOA. So Wi-Fi RTT is a technologies that allows computing the devices to measure the distance to a nearby Wi-Fi access point. So access point is the Wi-Fi router, okay? This is the Wi-Fi access point. We call it Wi-Fi AP. So based on the time differences, for example, the signal transmitted from this AP to this user, okay, the time difference is multiply the speed of the light. This is the distance. And as I just mentioned, the location of the AP is usually known variables. Okay, we can already get this location maybe from some geodetic solutions. At least, I mean, the location of the AP is known variables. And with a single Wi-Fi access point, only a distance measurement is available. Only one measurement is available. So as I mentioned, you need to determine the position of the user is at least XY or at least XYZ. It means you need 3 different equations, right? It means at least you need to receive 3 different measurements. You good? So it means at least 3 measurements are required to get a position. So with 3 or more nearby APs, so 3 or more. So for example, if you want to calculate XYZ, right? So you need at least 3 equations. It means you need to receive message from 3 different APs. More than 3 message from APs nearby. So can triangulate a device's location with an accuracy of 1 to 2 meters. Triangulate means this is the process of calculated location. For example, okay, 3 different informations, okay, 3 equations, right? You can solve it to get to XYZ. The process is called triangulation. Triangulation, okay? So later in the next lecture for GPS, we are going to have details for this one. Okay, the key features, okay, the point. The position of the Wi-Fi AP is access point. The Wi-Fi router are known variables. Okay, in this course, blue words represents the known variables. The red words represents the unknown variables. So the distance between the Wi-Fi AP and the user, for example, smartphone, are known variables. So the distance from this Wi-Fi point to this user is known variables. This is received from the TDOA. So the location of the user are unknown variables to be calculated. So at least 3 or 4 APs are required to calculate the location of the users. At least 3 or 4. But usually in the indoor scenarios, we maybe have like more than 3 or 4. It's good enough to calculate your locations. Yeah. This is Wi-Fi RTT. So this is the principle. I mean, yeah, this is the physical principles of the Wi-Fi RTT. So you don't really need to like to memorize those stuff. It's not good enough. It's not necessary, but we just quickly go through. Okay. So the process is like this. Left side smartphone. Okay, the smartphone. It will first send a Wi-Fi scan to the access point. Okay, to inquire a question. So to ask us, so do you have the RTT? It's capable because not all the Wi-Fi routers can provide the RTT measurements, can provide the range measurement. So first it will inquire this access point. So okay, first to inquire this, to check this RTT is capable or not. And then you can make a request to get a range. Make a request to this one and to get a range. So FT means find timing message, but no need to remember this one. To start a message, I mean, by finish the 2 times, okay, 2 rounds of communication, it can provide directly tells you what is the distance from this to the mobile devices, So again, so first send the Wi-Fi scan from smartphone to this access point to the router. Okay, to ask, okay, do you have the functionality of Wi-Fi RTT? If yes, it will go through these 2 components. If not, if there's no RTT function, okay, it will stop this, will not do this 2 requests anymore. So the right side is a physical model. Okay, the right side is a physical model. So first one is a request. Okay, it will go through for 2 times. And for example, okay, this is access point. This figure looks quite complex, but it's quite easy to understand. So this is access point. Okay, this is a mobile devices. So for example, this is a Wi-Fi routers. The upper part is the smartphones. Okay, so the first, okay, it will send the FTM message. So FTM means a fine-tuning message, fine-timing message. Send the request to the access point, and it will reply. Okay, acknowledge. ACK means acknowledge. Okay, ACK message go back to check. Okay, if this router have the RTT function or not. Okay, so it means this and this is only a very quick communication to ask if you have the range function or not. Okay, this is nothing related to the range, but it's only to double check. So after that, let's going to be start with the range. So for example, this is a timestamps at the router at the access point. So this message will send back to the users. Users means, for example, the smartphones. Okay, the mobile devices. So the time difference is from first one to this one. Okay, and wait. For example, like wait for a short period. Okay, the short period is like this. Okay, the mobile devices will send one more message back to the AP. Okay, send one more message back to the AP. So the timestamp is like this. And wait for a moment. It will send one more message back to the mobile devices. So you may ask a question in your mind. So why we need to do this for several times? Why we need to do this for several times? So this is represented by this equation. So for example, tau 4, this one, okay, minus the first one, and minus tau 3 and minus tau 2. This process can help you to eliminate the clock differences. For example, okay, in the mobile devices and access point, so the time differences can be calculated by, okay, you can minus the T2 to T1. So this is based on the assumption that the clock is fully aligned or synchronized between the two clocks. For example, you have a clock in the AP, right? You have one clock in your smartphones, right? You need to make sure they are in the same clocks. Of course, it's going to be not, because the accuracy of the clock is different. So by doing this 2 times of the minus, the difference can be eliminated. I mean, this 2 times of minus can help to eliminate the clock differences between the AP and the user side. Okay, so by doing this, if you eliminate the clock differences, okay, so if this n is 1, okay, usually we make this n to 1, just make 1 time is good enough, okay? So this is going to be 2, because you have 2 range, okay, divided by over 2, it means you are going to be, okay, because you have to do this 2 times. So after this only represents the clock drift free range measurements. It means this can directly provide the range distance from the AP to the Wi-Fi, from AP to the user side. Okay, this is to eliminate the clock differences between the user side and the access point. Okay, so for example, this D is the actual distance, right? This is actual distance between the Wi-Fi point to the smartphones, and this is equal to the exact distance plus the noise. For example, there's some noise coming from the receiver design. So this is the Gaussian noise. So this is exact distance. So BI is some bars coming from the protocol. Okay, you can just understand this is a fixed term. Okay, so BI measures the error between, for example, like due to the MAC access transfer delay, and also for AI, I just mentioned this is corresponding to the Jeremy Gaussian noise, okay? But we still have a clock error because we do the elimination, but still have a possibility that we cannot 100% of eliminate the clock errors. But at least like majority of the error terms coming from the clock errors are eliminated. Okay? So this is good enough. You understand, like you don't need to really understand how this clock error is eliminated, but generally this is done by this 2 times of the minus to eliminate the clock errors between the AP and the users. So finally, we get what? We get the distance from the access point to the mobile devices. And one more thing is, this Wi-Fi RTT based methods don't have the privacy issues, because for example, like you only send a message to the AP if you will not have the information of where you are. You see, because you only have a request. your positioning information will not be shared to the AP. It's different. So it in this case, it don't have is only requesting the devices can determine it only requests a range. The position information will not be shared to the AP, so it don't have the privacy issues. And usually the accuracy of this range is around like 1 to 2 meters in the open sky. So for example, if this is a Wi-Fi routers, right? If this is smartphones, the distance measuring is usually around 1 to 2 meters. But if the signal is reflected by the buildings, it's going to be different stories. That's why in the open sky, in the open areas, the position accuracy, from the range is around 1 to 2 meters. So if in the indoor scenarios, like accuracy is not guaranteed. So that's why a lot of researchers are working on this topic about how to solve the problems of the signal reflection of the Wi-Fi IDT. So this is roughly about Wi-Fi IDT. So this, the Wi-Fi IDT, this can already be a lecture, but only one page. So it means you don't really need to like understand the physical model side, like protocol styles, no need, okay? Just generally understand, okay, so the Wi-Fi IDT can provide a range measurement, and the accuracy is around 1 to 2 meters, and this is based on the 2 times of request. And okay, this minus is to eliminate the clock errors. So because this is elective, maybe in the future, if you're really working on this topic, so for example, we have 2 PhD working on like how to improve the RTT positioning in indoors. So you can learn, you can dig into this models. Okay. I think this is also the essence of elective, okay? Provide the general knowledge for those parts. So any questions for this part? Okay, let's finish. Okay, let's finish the Wi-Fi RTT part first, and then we can take break. So limitation is like Wi-Fi RTT, the range is usually around like several meters. It's different from GPS. GPS can measure a distance around like several thousands of kilometers. But for the Wi-Fi RTT, it's quite limited range. Also, it have the alongside problems. For example, if this router AP is installed in another rooms, we still can have access to the Wi-Fi, but the range distance is not going to be accurate anymore because it can be reflected. For example, the Wi-Fi router is installed in another room. The signal can be reflected by this wall and finally received by me. Of course, this reflection transmission did not really reflect the exact distance. That's right. Okay. So the long side requirements is like the basics. Okay, we need to directly see the Wi-Fi access point to make sure the distance range is correct. Okay, so this is the limitations of the range and the long side. Okay, long side means this should be within your site, within your field of views, within your site. So the principles of this signal transmission can be formulated by an equation. So in the previous page, we mentioned, okay, so if you get a range of the Wi-Fi signal, okay, we can directly calculate the receiver's location because the AP's point is available, right? So this is the first solution for the Wi-Fi positioning. Okay, this is the first solution based on a range, okay, based on a range. So the second solution is called fingerprinting, okay? So take break for 5 minutes.
This one.
Okay, so let's go back. Let's try to finish this part before 6. So I just received message from department. I mean, the typhoon number 8 maybe like enforced until like in the afternoon tomorrow, like 12 o'clock tomorrow. You can just keep track of the information from the university, okay, to see if you still need to attend the lecture tomorrow or not. Okay, you can keep track of the information from department. So okay, so as we mentioned previous page, we talk a lot like, so for example, this is a Wi-Fi access point. We can, okay, get the distance, the range distance from the Wi-Fi access point to the users, right? So because the Wi-Fi AP, the position of the access point is a known variables. So based on 3 different range, based on 3 different positions of the AP, we can calculate all locations. That's correct, right? So this is the first solution to get your position, okay, based on a range measurement. So of course, another solution is like, so it's called fingerprinting. So this is a process of a signal collection and association with the indoor location. So this page looks complex, but actually it's quite easy to understand. So for example, we install several Wi-Fi access point. Okay, for example, this first one installed here. The position of the Wi-Fi access point is fixed. So at each location, so theoretically, the signal strength of this, for example, okay, for example, the first Wi-Fi access point is installed at this location, okay, because it's fixed in here, and the scenario of this indoor is fixed. So theoretically, at each of the location, the signal strength should be kind of to be stable, right? So for example, the signal strength, okay, denoted by the dB, okay, denoted by the dB. For example, the signal strength is of the Wi-Fi access point usually around 19 to 32 dB. So for example, if I'm quite close to the Wi-Fi, okay, AP, okay, my signal strength received by this AP should be around the top value, okay, 32, right? So if I quite far away from, it should be around the bottom, okay? The low bound, okay, the 19 dB, okay? So if I in this middle, okay, the distance is like the middle range, the signal strength should be around like maybe like 25 something, right? So it means at each location, you should receive like kind of stable signal strength. So for example, if I stay here, the strength of this AP should around 20, around 16. So by assembling all those signal strengths, you should have you can get a heat maps, right? The heat map, the color represents the signal strength you receive. So for example, the deeper color means you get stronger signal strength. For example, the more blue, okay, you get more stronger signal strength. That means this color means something. For example, if you receive the signal strength belongs to the like strong, it means you should at least belongs to the blue area. Is that correct? It's like a matching process, right? So if you also receive, so it means if you receive one signal from one AP, at least you belongs to the blue area, okay? And you receive the signals from second AP, maybe you belongs to this area. And by doing this, by considering all those information from different APs, you can do the matching. Matching the signal strength you received and the theoretically the signal strength you should receive. Okay, this process is called fingerprinting matching. The fingerprinting is corresponding to the color. So again, so the process is like, if I quite close to this AP, the signal strength should be quite strong, okay? Maybe like 32, okay, dB. And if I quite far away from, the signal is going to be attenuated. It's quite weak, around like 19 dB. So it means for each of the location, the signal strength should be like kind of stable or fixed value. So in this case, we can collect all the signal strengths at each of the grid. You see a lot of grids. You can collect the signal strengths of all those different locations. It means you can have the map, the strength map. Okay, it's like the heat map. Okay, the color represents the strengths. It means next time you receive the signal strength at any location like 19 dB. Okay, you can just search in this map. Okay, this is 19, 19, 19. Maybe you have several options. Okay, let's do 19, 19, 19. It means one AP signal is not good enough. Maybe you can just combine another AP information. Finally, you can find, okay, probably you are going to be at this point. This matching process is called fingerprinting. So this equation represents the signal strength change. So for example, left side is PT is the original signal strength from the access point. So the PSSI is the signal strength you received. So the difference is due to the signal attenuation, right? So for example, the signal attenuation can come in from because of the diffraction stuffs. So this attenuation process is represented by 20 log 10f. So f is the frequency. Okay, this is the fixed term. Okay. So the n log 10d. So d is the distance. It means the longer distance, the signal attenuation is going to be stronger. It means the d is, this signal strength attenuation process is directly related to your distance. Is that correct? And the n here means how many floors. So for example, this is the Wi-Fi point. I receive a signal in the fourth floor. This is third floor, right? The fourth floor means n equals 1. So if n is 0, if rows are on the same floor, that's why you can still receive Wi-Fi signal in the different floors, right? So for example, in this Wi-Fi access point, I can still receive signal from the 5th floor, maybe. It's quite weak, but still I can receive it. But in this model, I can infer this differences of the floor change. That's correct. So finally, this 28 is a constant value. Fn represents the floor penetration loss. Okay, the n represents how many floor you go through. How many floor you go through. Okay, so in short, okay, let me try again. So this signal attenuation, the signal strength attenuation process represents how the signal goes through environments. So for example, like the d represents the distance. So in this case, if you collect all the signal strength map in this environments, okay. So if you get this map, okay, next time you get smartphone, okay, you receive signals, right? Okay, the AP, the first AP, okay, the signal strength is 20 dB hertz, okay, dB. So you can just search from this map to see, okay, maybe I here. Okay, you get several candidates. So by combining the maybe like 3 or 4 APs, you can finally get a most match location with the signal strength. So finally you get your location. It's quite easy to understand, right? The problem is what? Like accuracy is not guaranteed. For example, if someone is walking around, the signal strength is going to be changed. So for example, if everything in this environment, okay, you don't move, okay, the signal strength is going to be stable. If I just walking around, the signal is reflected by me or even digested by me, okay, so the strength is going to be different. So that's why the fingerprinting, the accuracy is not guaranteed. So I would say the fingerprinting matching, this position technology is the first generation. So the Wi-Fi RTT range-based is the second generation. So currently, for example, we have two generations of the indoor positioning technologies. For example, like for Google, so the Wi-Fi RTT is kind of like originally coming from Google Wi-Fi RTT based positioning solution. So if you know about Apple they use the UWB ultra wideband. This is another positioning solution. UWB is from Apple, but I mean, usually you would say Apple is good at advertisement. I'm not sure if you are some fans from Apple, so at least they are good at advertisement. So actually, the Wi-Fi RTT is more easy to be applied. That's why. Why? Because we have Wi-Fi access point almost everywhere. Because we need to connect Wi-Fi to surf internet, connect to internet. But for the URB, it's only for positioning. This is not good enough because it's hard to convince the building maintainer to set up a lot of facilities for the URB. It's too expensive. But for the Wi-Fi RTT, it's like additional attributes for the Wi-Fi access point. For example, in here we already have a lot of Wi-Fi access point. We don't need to like build additional facilities like UWB from Apple. Yeah, but Apple they say a lot. UWB is the future, blah blah blah. But currently, the Wi-Fi is currently more popular actually. Yeah. So okay, so this is the procedures. So this some summary. Okay, so the database fingerprinting. This is the corresponding to the heat map. Okay, the strength signal strength map of this different environments, and you can divide this this plan, maybe this indoor scenario, into a lot of grids, and for each grid you can like offline collect the signal strength map. Okay, for example, in here the colors represents the signal strength. Okay, signal strength. So any questions? So just now, at this point, we have mentioned two solutions for the Wi-Fi positioning. The first one is range-based. The second one is Wi-Fi fingerprinting matching-based. So at least the two different topics currently they are all quite hot in the academia. So especially for indoor positioning. So you can think of a question. So for outdoors, we have but for indoors, the Wi-Fi RTT, the range-based Wi-Fi RTT, this is more like an indoor GPS. So the Wi-Fi RTT, the AP access point is more like a satellite. It's similar to the GPS in outdoor. So that's why, but you know, especially in the summer times, majority of us are staying in the indoors, right? So indoor applications for the indoor position service is very important. It's a hot topic. It's a hot topic recently in academia. So the process is like, for example, okay, this is a video. Okay, later I will show this. This is the access point 1, 2, 3, 4. So this is a Python-based example. Okay, you can also have access to this example from the website. Okay, from the GitHub. Okay, later I will show you. So 1, 2, 3, 4. Okay, you get 4 different access points. So actually, the user's location is at this point. Okay, so I'm going to show this video. The video shows it's like a searching or iteration process. So this positioning process is based on the first solution, based on the range. Okay, so the range is, from this point to this, you get 4 different access point, you get 4 different range. and the position of the 4 points, the position of the 4 AP is available, it's known variables. So by doing the gradient descent, okay, in the next lecture, we are going to talk about the gradient descent, the least square. So why we need the gradient descent, as I just mentioned. So if you get 3 equations, you can solve it efficiently, okay, based on what you have learned from high school. So if you get 100 equations of 10 equations, it's almost impossible to solve it using what you have learned from high school. So in this case, you need to have some diligent equations, it's called gradient descent, to gradually find the optimal solution. So this is most importantly useful for GPS. So also this can be used for the Wi-Fi RTT range. So let me show you the code, okay? So as we mentioned, we have actually we have a GitHub repository. Okay, just open this. Open this, you are going to find the sample codes, the web RTT. Okay, we also provide but yeah, we provide very detailed explanations. It's a pity if you after this lecture, because I have no qualified for this, no assessment for this. I don't request you to write the report, but fill all those information. It's a pity if you don't look back to this one. So now we provide the explanation about least square and the comments of all those codes. And over this one, you're going to find the codes. As we mentioned, we provide the links. Okay, in here we provide the link for the online. I don't know what's the name for this one. You can call this is the online editor to run the code in Python. Okay. So this editor, just click this Python, and you can copy all those codes here. Okay, let's look into a demo first. And next I will show you. It's a image. Okay, so here you see this is the result. Okay, this is the result, and also we should have a GIF. So later with one. So okay, this is the access point. Okay, we get 4 access point, the red circles here, and actually the ground truth location of the AP here. We start from, it's like a gradient descent process. We start from this point by doing the iteration, and finally we are approaching the optimal location. So in the next lecture, we are going to talk about this gradient descent process. So if you look into the code, okay. So for example, in here, okay. So because you have okay, so you have some basic background in the Python, right? So for the first one, we just import some libraries like the NumPy, okay? The second row, is clear? Okay, so first one I import NumPy. Second one is about the import the least square. So because in the Python, it can directly provide the very basic functions for least square process to solve the problems. And the third one is like matplotlib is plot something. It's a library to plot the figures. So this is the location. Okay, you can set up locations of AP123. AP means access point, the position of the Wi-Fi routers, right? So the position is 0060. Okay, this is the location of the access point, and this is the distance from the. This is the measurement distance from the user, okay, to the Wi-Fi access point. So for example, distance 11 meters, 9 meters, 7 meters, or 13.5 meters. So this is the results. We want to define a variable to save the results, right? Okay, this is the functions. Function define the receiver. Okay, so first we need to calculate X, Y, Z. Okay, this is the location of the IPs, and this is the predicted range. This is corresponding to the distance differences. Okay, in the next lecture we are going to talk about the least square process. So we are going to understand what is the residuals, and what is the predicted measurements. Actually, this is corresponding to the differences between the exact measurement and the expected measurements. So for example, okay, so X is the location of the users, right? XI is the location of the APs. So this is the distance between the user and the AP based on your position, based on your estimated position. You see, XYZ is the position you want to estimate. So later on, you can look back to this equation and you can tune the parameters to see how, if you set the different position of the APs, you're going to see different results. So I think this is the power of the code, example codes to help you to understand. So the difference is, this is called residuals. Residuals means push this value to the vectors, okay? So if you get this function, you can get the residuals of the for different measurements. Okay, the initial guess, okay. So at the beginning, you have no knowledge about where you are. Okay, you can just guess 0, 0, something is good enough. So okay, use reuse function, you can get the results. Result is your position. So later on, some functions to plot the figures. Okay, it's nothing new. So for example, this is some functions to plot the figures. So as I just mentioned, okay, this is the location of the APs. For example, this location is 6, 0, and Z is 0. And this one is 0, 0, and 0. Okay, this is 0, 0, and 6. So based on these 4 different locations, you can calculate the location of the users in the green point. Okay, so after this lecture, you can look back to this code and you can replicate the codes. You don't need to install the Python stuff, just use this Chrome. Okay, use this web, you can easily replicate the demos. So maybe you can take a try. Okay, 10 minutes, take a try to see if you can replicate the demos. Okay, try in your computer. Okay, I see you all take a. So Chen Jun, you go here to take a try. Okay. You didn't take your laptop? Did you take your laptop? You can try in here. Okay, you can take a try. I can open a new Chrome for you. Okay, you can take a try. The code is over here. Okay. You can refer to the slide. You can refer to the slide here. Yes, you can take a try. And also you can tune some of the parameters. For example, location of the APs. And take your time. Yeah, just open a new Chrome. Okay. Yes. And also, all codes, like 90% of the code can be directly obtained from ChatGPT. I'm quite confident. Yeah, that's why the first way I tell you that we can make good use of the ChatGPT. Wait a moment, maybe you can get result in 7 seconds. You scroll up, see if there no results. Oh, wait a moment, you can try again. Maybe just click the wrong button. Yes, click again. Wait a moment. So maybe you can try click the save. There's a button. Upper left, 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 left. Yes. I'm not sure it works or not. You can try. Rename, save it, and you can run again to see it works. Maybe you can close my page. So for example, you can close this page, see it works or not. Do you have ever used Python before? No? Yeah, maybe you can just copy the code to this button. Yeah, to this page. Try again. You see, for this one, you can run a result. Maybe you can copy to this page. So can you replicate the results in your yes? Sanjin, can you take a try to solve? You see, you click, there's no response, right? Can you try to search from online to see how to solve it? You can try. Take your time. Take your time. No assessment. So for example, Chenjun, so for this time, you see, you get the problem in run the code in the Chrome. You can raise the issue. Just example, you can raise the issue in the GitHub repository this time. So in this case, so for example, this time another student also have a similar problem. So they can just refer back to your issue. So if you raise the issue, I will try to, for example, invite our TA or me to reply to you to figure out the solution. So that's why I suggest we use the gap in this lecture. Okay, we can try to solve it. So you see if you input some symbols. It's very weird. If you put some simple code, it works. So, okay, no problem. Okay, I can try. Yeah, maybe in the class you can take try in your own laptop. So. Save a draft in here. So I just open a new page and it works. This is for example, if I change the locations, the AP location, for example, this 8, 6. Maybe I change this 4. Oh, it's going to result. You see, if I update the location to 4, this is 4, right? 1, 2, 3. This is 4. So you can change the location of the APs. Okay, I mean, after this lecture, you can just change different location of APs and the range to receive different results. Okay, so let's go back. So in this moment, we have finished the Wi-Fi, the basics of the Wi-Fi. 2 different solutions for the Wi-Fi. Okay, the first one is based on range. Okay, the second one is based on the fingerprinting. So we provide the demo code, the sample codes for the range-based positioning. Okay, so the accuracy of the Wi-Fi is limited by the scenarios. So for example, especially in the indoor scenarios, if the indoor is pretty high dynamics, if the pedestrian is walking around, of course, the signal attenuation model is going to be different, right? And also if this is like constructed environments, a lot of walls, it's going to be signal going to be reflected. So in this case, the range measurement is going to be inaccurate. So in this case, the accuracy is around 1 to 2 meters for the Wi-Fi DT, especially in the open areas, especially there's no blockage or no reflections. Okay, so this is roughly the summaries for the Wi-Fi DT. So currently we have a lot of devices, for example, like Xiaomi. Okay, the latest model from Xiaomi. Okay, they support the Wi-Fi DT based positioning. They support the Wi-Fi DT based position. So you can see, so the Xiaomi, they use the Android system, right? Android is from Google. Google supports the Wi-Fi DT. So that's the reason behind. So for example, the Samsung, okay, they also support the Wi-Fi DT. And Google, they also provide the routers, okay, the access point is like this, okay, the white access point. So it means you can use this to do research, okay, to do research to collect the raw range measurement from Wi-Fi DT. For example, if you find the accuracy is not good, so you can just dig into the details to see. So why the position accuracy from Wi-Fi DD is not good. So to see how can improve it. Okay, you find the solutions, you get a paper, get something like this. So this is going to be a PhD. So this is Wi-Fi DD. Okay, we have a lot of different devices currently support the Wi-Fi DD positioning. So another example is like called angle of arrival. You see, for different transmitters, TX1, TX2. So the position of the TX1 and TX2 is known variables, and the unknown variable is XY. So the unknown variable is XY. So the measurement here is not the range. So in the previous page, we show okay, the measurement is a range. So the measurement here is the angle. So the measurement is the angle. So that's why it's called the angle of arrival. So the measurement is the angle of this theta 1, theta 2. The measurement is the angle. So based on this two information, we can also get the intersection, right? Intersection of the two direction is the location of this user location. So in this case, we can get the equations, right? So for theta 1, we can get the equation of y1 minus y over x differences. Okay, this should be equivalent to the tangent theta I. So for second one, okay, we can get the similar equations. Finally, we can get the two equations corresponding to the theta 1 and the theta 2, right? So in this case, we get two equations. And also we can write this equation into the matrix. So this equation can be written into a matrix. For example, if you multiply this, you can reverse back to these two equations. So in this case, you can get the matrix. So the unknown variable is xy. So this is the known variables. This is known variables. So in this case, you can calculate the x. You can calculate x equals to a inverse b. Okay, you can calculate a inverse multiply b. Okay, so in this case, you can get the x. So for example, if you get 100 tx1 to tx100, okay, you get 100 equations, you're going to be crazy to solve these equations, right? So if you write this equation into a matrix form, you can easily solve it with maybe like Python. Okay, Python, a lot of matrix calculation libraries, you can solve it efficiently. So this is another model. This is called angle of arrival, okay? So for this one, any questions for this one? Okay, so okay, I think we can roughly stop from here. I'm not sure number 6 is coming, but at least according to a suggestion. Okay, I will stay here for additional 5 minutes. So if you have any questions, you can come here. So if you have no more questions, okay, we can dismiss. Okay, you can leave early. Okay, stay safe. Stay safe. Okay, any questions? Just feel free to come.